These are the notes for Algebra 1A, Section 02. We are going to talk about number sets, so in particular the real number system. So we have real numbers and we have imaginary numbers. So imaginary numbers are something that you will learn about when you get into Algebra 2. So for now, we're going to just talk about the real number system. So everything that we have on this page is considered a real number. And then from there, they break down into like their own separate categories. So we have symbols that we use for our numbers to categorize our numbers. Anything that is a real number, you use this R for, and that means the real numbers. So if you find that you have a number that's a rational number, you can call it both a rational number and a real number. So our rational numbers are any number that you can write as a fraction. So you can take the number 2, put 2 over 1, you could make it a fraction. That's a rational number. So the root of that is ratio. So anything that can be written as a ratio or a fraction. And then when you talk about the decimal version of that, the decimal is either terminating, which means it ends, or is repeating, which means you would have like for example, 1/3, if you put that into decimal form, that will give you 0.33333, and it would just repeat forever. So that would be considered a rational number. So examples of that, 1/2, that can be written as a fraction, but then when I look at the decimal version of that, that's 0.5, and it just ends right there. And then 1/3, that's the fraction. If I plug that in my calculator and look at the decimal version of that, I would get 0.3 repeating. It would just go on forever and ever. I'm going to jump over here to our irrational numbers because those are just the opposite. An irrational number is a number that cannot be written as a fraction. And then the decimal version of it never ends and it never repeats. It just goes on forever and ever and ever. And the most famous irrational number is pi. And pi just goes on forever and ever. It never repeats. There's also another one. E is a number. They call that the natural number. You won't see that until you get into your higher math courses, but it is a number. Other examples would be like the square root of 2. Anytime you try to take the square root of a non-perfect square, it's going to give you an irrational number. It's going to give you a number that just goes on forever and ever. Okay, so for our rational numbers and our irrational numbers, again, we have letters or abbreviations we use for those. So a rational number, if you're going to categorize it, you use a Q. And for an irrational number, you use a capital I. Moving down to our integers. So our integers are just our positive and our negative numbers. And the way I usually think about integers is if I was going to draw a number line, these are the numbers that I would put on my number line. So it's all the positive and negative numbers. So and they go to infinity. So to negative infinity to positive infinity. So forever and ever, and then -3, -2, -1, 0, 1, 2, 3, and so on, all the way up to positive infinity. So that here, what I just wrote, that's set notation. So it's the set of numbers, and we indicate a set by using these curly brackets here. It's the set of numbers that goes from negative infinity all the way up to positive infinity. But it does not include things like 1/2 or 1/3 or any fractions. Then when we talk about our whole numbers, so our whole numbers, it's the integers, but it's without the negatives. So it's only the positive numbers and 0. So again, it would be the set of numbers that includes 0, 1, 2, 3, and I could just keep going forever and ever, all the way up to positive infinity. But as you can see, our whole numbers does not include the negative numbers. And then the last one, these are our natural numbers. These are just our positive numbers, otherwise known as our counting numbers. So if you were going to start counting, you would start at the number 1. Let me redraw that. So you would start counting at the number 1. You would not start at 0. So your natural numbers do not include 0. So this would be 1, 2, 3, 4, so on and so forth. So again, these are dots here. It's the set of numbers that includes 1, 2, 3, 4, 5, 6, 7, 8, all the way up to positive infinity. Okay, and then our abbreviations we use for these three. For an integer, use this Z. Kind of looks like this actually. But a capital Z is just fine, but it looks like that. The whole numbers, that one is just a W, so that makes sense. And then your natural numbers, that's an N. So a lot of these make sense. So N for natural, W for whole. Don't ask me why they use a Z for integer, but that's going to be one that you have to kind of try and remember. Z for integer, I for irrational. That one's easy to remember because irrational begins with I. And then your rational numbers, Q. Not sure, again, where that came from, but that's how they label that. Okay.